Let's start talking about operations with rational numbers for this one. This would be section 04 and 05 um, for our Algebra 1 students. So we have a couple different things already laid out up here, but we'll kind of talk about them in a few different ways. Most of these examples are pulled from the Algebra 1 book that we use, but I'll kind of talk about them too. To get started, I have two rational numbers up here. Remember, if you watch the types of numbers video, maybe I'll try to do the thing where I put it up in the corner. I don't know if I know how to do that or not, so you'll have to tell me if it actually worked. But if you remember from the types of numbers video, then you know that a rational number is anything that can be represented as a ratio or a fraction. So that's what we have here, 2/3 and 5/6. Our first kind of task with these is to, in the middle, put either greater than, less than, or equal to. So to do that, and that's going to be kind of our strategy with the rest of these, we want to rewrite these so that the denominators, the bottom numbers, are the same. So we need to think about how can we change these, make one bigger, make one smaller. More often than not, you're going to make the smaller denominator match the bigger one. So I need to think about 3. How many times bigger is 6 than 3? Or basically, what do I need to multiply this by to match this? So I think for a second, and I know 3 times 2 would give me this 6. So what I can do is I can multiply both the top and the bottom, because I need to keep it equal to what it originally was. I can multiply that by 2. So 2 times 2 would be 4. And then 3 times 2 would be 6. And now the denominators match. So, change markers here. Now that they have the same denominator, I can tell, okay, 4 is less than 5, so I would know I would write 4, 6, and then my less than, like the alligator mouth pointing away, and then 5, 6. So that kind of rewriting tool that we did for this one, that's going to be the game plan for the operations as well. So let's think about that before we move on to either of those. Let's talk about adding and subtracting with rational numbers first. Anytime that you are adding, so let's go back to what we had originally, the 2/3, let's say it was plus 5/6 originally. Anytime that I'm adding, my goal is going to be to rewrite to where I have that bottom denominator the same. So we already know what that is. 4, 6 plus 5, 6, and now we're here. When these are the same, I can just add across the top, and I'll know that 4 plus 5 is 9, and then the bottom number stays the same. So if I have 4/6 and I add on another 5/6, now I have 9/6. Now that can reduce. So you would kind of think about what you could take out of both of those, or kind of what you could divide out of both of those. I can look at 9 and 6 and see that I would be able to divide out a 3 from both of those. So if I take 9 divided by 3, I have 3. 6 divided by 3 would be 2. So if you were asked to simplify, you would go to this final step here. The reason I know that's simplified, there's no whole number that I can divide both of those by. I believe if you're doing an IXL that's assigned for my class specifically, the ones early on will probably take this, but as we get a little bit more advanced, they'll probably ask you to simplify. It's kind of all in the wording there. And then I said I would mention subtraction as well. Works basically the same way. I guess we'll just put that up here. I'll flip-flop so we don't get any negatives quite yet. We'll save that for over here. 5/6 and 2/3 was the original. if I'm subtracting, basically the same thing as the addition. Rewrite this as the 4/6 that we know it's equal to. The denominators stay the same, so I know in my answer I'm going to get 6, but 5 minus 4 is 1. So I can kind of think about it this way, justify. If I have 5/6 of something and I take away 4/6 of that, I only have 1/6 of it left. Now this doesn't simplify kind of like this one did, because if I think about a 1 and a 6, there's no whole number that can be divided out from both of those. That would be our final answer there. That's where we would stop. So even if it said simplify for that one, that would be the stopping point. Okay, so let's go ahead and move past this one. We'll be up in the corner here. I have 3 different rational numbers listed, 4 and 5/9, 10 and 6 1/3. For that, we're just going to ask to put them in order, so like least to greatest. My suggestion, and I think the IXL that kind of goes with this one, treats it a little bit differently, and I wouldn't suggest it because it might be more simple for that specific assignment. But moving forward, the way that I'm going to show you is going to be a little bit more beneficial, I think, and it's going to have less errors. You'll be able to basically do the same thing every time. So my suggestion is anytime you have kind of a mixed number like this, where you have like the whole number out in front and then the fractional section after, let's take the whole number portion and kind of add it in. So if we're using 9ths here, if that's what we're using, I need to think about 4 and rewriting it as some number over 9. So 9/9, so the same number on top and bottom, would be equal to 1. And if we're using that same logic, 18 over 9 would simplify to 2. And then 27 over 9 would be 3, and then 36 over 9 would be 4. So this 4, just talking about that part, is the same as 36 over 9, and if you plug that in the calculator, 36 over 9, you would simplify and it would spit 4 back to you. Another way we can think about it is if we were simplifying like this, is there a number we can divide out of each of those? Yes, and it would be 9. 36 divided by 9 would give you a 4 on top and a 1 on bottom. So I don't think you can see that very well with the glare, but just kind of proving the point again. So if I have 36/9, and there's also an attached 5/9, those have the same denominator now, so they can add together. So 36 plus 5, that's going to give me 41. Now I know that this whole thing is the same as 41 over 9. I think, at least going forward, it's going to be at least easier to deal with just one fraction rather than kind of that mixed situation up there. Since we're already dealing with something in terms of 9ths, let's change that 10 to something over 9, following the same kind of method that we did to get that 36. Well, 9/9 would be 1, 18 over 9 would be 2, and so on. So 90 over 9 would be equal to 10. And just between these two, now that they have the same bottom number, I can definitely tell that's bigger. I could before 10 being bigger than 4, but now it's a little bit more obvious. And then 6 1/3. So I would need to kind of treat the 6 the same way as the 4 over here. And we're dealing with 3's as the denominator this time. So 3 over 3 would be 1, 6 over 3 would be 2, 9 over 3 would be 3, and so on. And we would actually get that 6 being the same as 18 over 3. And then there's also a 1/3 there. If I bring those together, kind of like this, I'm going to end up with 19 over 3. And then we notice they're different denominators, and I want to be able to compare them. So to get from 3 to 9, I need to multiply everything by 3. So now my new bottom number is going to be 9. Then I got to think about 19 over 3, 19 divided by 3. Well, I know 20 times 3 would be 60, so this would be 57. So now we change this into this. And if I want to put those in order, now that they're all the same bottom number, I can just rearrange the top one, so I know it would go 41, and then the 57, and then the 90, so I'll have to move those around. So now I know that I can compare between denominators, and now I know it goes 41, 57, and 90. So it helps us to more easily compare those original 3 values. And then let's do something similar with the last one. So we have some decimals and a negative thrown in here. With the 0.11, we'll call it that right now. Well, we know that's the 10th place and that's the 100th, so because it goes out to the 100th place, what I am allowed to do is I can do 11 over 100, and that would be the same thing. Kind of like if I didn't have that there and just the 1, just this one, it would be like 1 over 10, because it's the 10th place. I have 1 over 9, we'll deal with the fraction and changing those in a second. We have a negative 0.5, that 5 is in the 10th place, so I can do negative 5 over 10, and then 1 over 10. So right now, I see a negative number, so I know that's going to be at the very beginning. And then I know between the 1/9 and the 1/10 that the 10th is smaller, but I don't know about the 11th over 100 quite as much. So let's compare those real quick. To get from 10 to 100, I would need to multiply this by 10, meaning I would also multiply this by 10. So 1 times 10 is 10, and 10 times 10 is 100. So I could rewrite it that way. So now I know out of these that 1/9 is bigger than 1/10, which is what that is. And then I know that this one is smaller than that. Still want to be able to compare though. I can't really multiply 9 by any whole number though and get to 100. What I can do is change kind of everything. So, because I have a 9 and a 100, what I could do is multiply both things up and get to 900. So if I multiply this by 100, I get 900, and that would be 100. So that's the same thing, just kind of reiterating some fractions right here. If I multiplied this by 9, it would be 900, and then this would be 99. If I multiplied this by 9, it would be 900, and this would go to 90. So now, out of these 3, remember I'm leaving this one at the beginning because it's a negative. I don't even have to really compare that to the others because the other numbers are positive. They're obviously bigger. Well, 90 is smaller than these 2, so it would be next. 99 is the next number in the order. And then 100 would be the biggest one. So that tells me from my originals, it would go this one, and then I already flipped these, it would go the 1/10, and then the 11 100ths, which we turn into 99/900, and then 1/9 or 100/900. All right, so after that, let's take a look at some multiplication and division, and then we'll wrap up, so we'll clear this up. To be fair, we're focused on operations. My board's getting all dirty here. That's alright. That wasn't much better. Okay, so let's find a good example. Let's use, so we don't even need this anymore. 2/5 times 1/3. So they have different denominators again. Multiplication is really nice. Numerators, you just multiply across the top. Denominators, you multiply across the bottom. So basically all we have to think about is what is 2 times 1? That's 2. 5 times 3 is 15. So now I know that if I multiply across the top, multiply across the bottom, I end up with 2/15. Now this doesn't reduce at all because there's no whole number that can divide out of both 2 and 15. Multiplication, not so bad. Division. So let's say we use the same numbers. I don't like to use this symbol, but because this is technically, you can think about it as a ratio, division, fraction, it's all kind of the same thing. But let's say we're given that. The only twist that you need to do to change it to something as simple as this is when you're dividing, the second number gets flipped. So the denominator becomes the numerator and vice versa. So what we could do is we could rewrite this as 2/5 times now. And then if we flip that, 3/1, this and this are the same thing. So now I'm going to use the same strategy as up here. 2 times 3 is 6. 5 times 1 is 5. Again, there's nothing I can divide out of each of those, so that would be my final answer right there. And it makes sense that I get something that's bigger than 1, because 1 would be 5/5. Because when you divide by a fraction, you get a bigger value. Okay, so we'll wrap up there. Remember that is sections 0, 4, and 0 to 5, and hopefully those helped.